So the opening problem, we need to state where the graphs of y equals sine x have been translated to and by how many units. So this one here, well, this has been moved to the right by pi on 6. This one down here is moved to the left by pi on 2. That, of course, is because plus signs move things to the left and that minus signs move things to the right. Y equals sine 3x minus 5 pi on 3. Well, how much has this gone to the right by? Well, it's going right by 5 pi on 3. Now, the next one is different. Because of that 3 inside there, that 3 will affect, whereas the 3 was on the outside of the bracket, the 3 is on the inside of the bracket here. It's actually going to affect the translation. This is actually going to go across to the right by 5 pi on 9. We divide by 3 here. So similarly, this will go across by pi on 4, whereas this one will actually move to the left by pi on 4 divided by pi, which is equal to 1 on 4. It's actually going to move to the left by a quarter. So these sorts of same rules apply for cosine graphs as well. So we're going to attempt to sketch some of these graphs. Sketch the graph of each of the following showing one complete cycle. State the period and the amplitude and the greatest and least values of y. So we've got y equals root 2 sine 2 brackets theta minus pi on 3. So the amplitude is root 2. The period is 2 pi divided by 2, which is equal to pi. And it's been moved to the right by pi on 3. Okay, so this is where things get a little bit challenging. So it's moved over to the right by pi on 3. So one of the things I'd recommend is just doing a sort of very rough number line. Again, breaking up into having little quarter bits. So 1, 2, 3. So we know instead of 0, it starts at pi on 3. And we know instead of pi, it starts, because that's the period, it's pi plus pi on 3, which would be 4 pi on 3. So the halfway mark would have normally been pi on 2. So the halfway mark here is pi on 2 plus pi on 3. So pi on 2 plus pi on 3. So what's that going to be? Well, that's going to be, we'll put a 3 and a 6 and a 2 and a 6. That's 5 pi on 6. And then what we'll need to do is we'll need to get the in-between bit. So pi on 3, so half of pi on 2 would be pi on 4. So this will be pi on 3 plus pi on 4. So this is going to be, we'll go into 12ths now. So pi on 3 plus pi on 4. So that's going to be 3 pi, and that's going to be that's going to be 4 pi, and that's going to be 3 pi. It's still 7 pi on 12. So that's 7 pi on 12. And that will, and then again, pi plus this one here, 5 pi on 6 plus a pi on 4 is going to make that 10 pi on 12 plus 3 pi on 12, so that's going to be 13 pi on 12. There we go. So we're dealing with pi's on, so one thing that might be useful is just having everything as the same common denominator. That would probably be helpful. So we'll have this as pi on 12. So that's going to be 16 pi on 12. Yeah, so here we go. So pi on 3, 7 pi on 12. So pi on 3 would be the same as saying what would it be over 12? It would be 4 pi on 12, so it actually starts here. So it hasn't gone upside down, so that's fine. And we know that pattern ends there. So what's the next one there where the turning point would be? So 7 pi on 12, so it's going to be here. So we better get our amplitude written here. Let's make that root 2. Let's make this negative root 2. So 7 pi on 12 is about there. And then we've got 10 pi on 12 will be here. And then what's this one? It is I can't even read my own writing. 7 pi on 13 pi on 12 is going to be here. So we have that sketch. Now look at that beautiful, beautiful looking sketch there. Now it says one complete cycle. When it does one complete cycle, what it usually means is it wants us to start from 0. So if we were to continue that pattern back, so so what's the pattern here? So 1, 2, 3. So we're adding a 3 pi and 12 each time, are we? Yeah. So adding a 3 pi on 12. So 1, 2, 3. So that means that's going to be there. So it's going to be there, and it will actually be about here. So, and in fact, yeah, it'll be about a half. So what we'll just need to do here for one complete cycle is state what my y-intercept is. So that's going to be when theta equals 0. So y is equal to root 2 sine, so this is for the y-intercept, 2, 0 minus pi on 3. Y is equal to root 2 times by sine, this will be negative 2 pi on 3. Sine of negative 2 pi on 3. Whew, hootenanny, that's in the third quadrant. Reference angle's pi on 3, so that's going to be root 3 over 2. And it's a negative, so it'll be root 2 times negative root 3 over 2. So that's negative root 6 over 2. Which I feel like you can simplify, but no, I don't think you can. Negative root 6 over 2. Oh, actually, yeah, you can simplify that. So essentially all we need to do is just to cut it off where we would next have it. So 0, so it's, where's pi? So pi will be 12 pi on 2. So we can actually cut it there. So it's actually going to be about here. So one complete cycle means I have to go from here to here. So what we'll do is we'll erase all of our hard work from here. Go. And we have now drawn one complete cycle. So this is going to be pi, and this is negative, it's a gross root 3 on 2. We've got 0 root 3 on 2. We've got pi on 12 at negative root 2. We have got, this is 4 pi on 12, so that's going to be pi on 3. 0, this is 7 pi on 12, and that's root 2. That's 5 pi on 6, and that's 0. And that's pi negative root 3 on 2. And there is one complete cycle. Y equals negative 3 cos 2, brackets theta plus pi on 2. So this is moving to the left by pi on 2. Once again, we're going to get our amplitude, that is 3. That our period is 2 pi over 2, which is equal to pi. It's been reflected. It's going to be an upside down graph, and these always muck me around. Reflected x-axis. So once again, I'm going to start by just doing a very approximate sort of breaking things into quarters. So I know that the period, it will start at negative pi on 2, because it's moved to the left by pi on 2. We know that the period is pi. So this case, this end will be pi minus pi on 2, which will be equal to pi on 2. Because a pi, take away half a pi is half a pi. So pi, the middle section, which would normally be pi on 2, is pi on 2, take away pi on 2. So that's going to be equal to 0. And in between that would be pi on 4. So pi on 4, take away pi on 2, is going to make that equal to negative pi on 4. And so what would be normally 3 pi on 4? 3 pi on 4, take away pi on 2, is going to make that equal to 3 pi on 4, take away that, it's going to make that pi on 4. So, we've got a few things that are listed up our sleeve. We've got where it will start, it's going to start at 0 pi on 2. So we need to be able to draw one complete cycle. So I'm going to start at 0. We may as well keep these in pi's on 4s. That's going to be the easiest one. So that's a pi on 4. It's 2 pi on 4. It's 3 pi on 4. 4 pi on 4. So that's what we've got so far. So just so you remember, this is the cos. So, and it's an upside down cos. So it's actually going to, it would normally look like this. There it is. That would be what it looks like. So the 0 is actually going to be up here at 3. And this is negative 3. So it's actually going to go down to here. And then here. So that's where we would be at the moment. And then the next one would actually be up here. And should be up here. I think if we have done everything correctly, we should have got a very lovely one complete cycle. And confirmed on the calculator, we have drawn one complete cycle. When doing these, please always make sure that you've put in all of the endpoints and things like that as well. And when you're labeling these, always make sure to use the simplest most fraction.